cover the mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 13th video on single variable calculus of the chapter functions. In earlier videos, we discussed about piecewise functions like modulus function, signum function, greatest integer function and fractional functions. And also we discussed about their definitions, domain, the range, the graphs, some properties. In this video, we are going to discuss about some solved numerical questions based on properties of piecewise functions. Let us solve the questions one by one. Solve for x mod x minus 1 by mod x minus 2 more than or equal to 0. To solve this inequality, I have two methods. One is the actual method by removing the mod symbol, or we have another second method also. Now I am going to solve this question in both of the methods. Mod x minus 1 by mod x minus 2 is more than or equal to 0. So you have to remove the mod symbol. How do we remove mod symbol? By using the properties of the mod. What are the properties of mod? What is the basic definition of mod x here? When x is more than or equal to 0, my mod x is equal to x. And this is case 1, and case 2 is mod x is equal to minus x where x is less than 0. So first I will go for case 1 first. Case 1, x is more than or equal to 0. This implies mod x is equal to x. Therefore we have x minus 1 by x minus 2 more than or equal to 0. Now it became normal rational inequality. How do we solve? By real line method. So in the real line method, what we do? We solve numerator and denominator for x. Those are called zeros of numerator and denominator. Here zeros of numerator and denominator are 1 and 2. Now next step is take real line. Locate these two real numbers on the real line. Now you have to select which are the suitable intervals. Of course, this is minus infinity to minus 1 and a 2 to infinity are suitable intervals. Therefore, my x belongs to minus infinity to 1 union 2 to infinity. Here 1 is included and 2 is not included. You know very well what is the reason for that one. Then you have to get the final answer in this case. You have to take the intersection of these two. So how do you do? Again, I take real number. Again, take real line. Minus infinity to infinity. First one is more than or equal to 0. Somewhere I go for 0 more than. So this is 1. Number 2, minus infinity to 1. Somewhere here. And 2 to infinity. And which parts are common? If you observe carefully, these two are common. So in this case, therefore, my x belongs to 0 to 1 union 2 to infinity. This is number 1. X less than 0. When x less than 0, we have mod x is equal to minus x. Now remove mod and replace it by minus x. So we have minus x minus 1 by minus x minus 2 is more than or equal to 0. Or you can have x plus 1 by x plus 2 is more than or equal to 0. Now as usual, zeros of numerator and denominator are minus 1 minus 2. Zeros of numerator and denominator are minus 1 minus 2. Locate these numbers on real line, minus infinity to minus 2, minus 1, infinity. Now which intervals are possible? Now for that one, minus infinity to minus 2. Take a real number, minus 3 plus 1 by minus 3 plus 2. Possible. I want this. I don't want this. I want this. Therefore here I got x belongs to minus infinity to minus 2, union minus 1 to infinity. Now you need to take a common intersection part of x less than 0 and this interval. How? Again I take a real line here. First one is 0. I don't want 0, minus infinity plus infinity. Minus infinity to minus 2, minus infinity to minus 2. Somewhere here you have minus 2, somewhere here minus 1. Now minus infinity to minus 2 is this, minus 1 to infinity is this. So common part is this and this. Therefore the answer is here x belongs to minus infinity to minus 2, union minus 1 to 0. Okay, now is 0 is included? Let me check. When 0 is included, put here 0 plus 1 by 0 plus 2 is positive, so 0 is also included. This is number 2. Now you have to go for intersection part of, union part of 1 and 2. Therefore, final answer is 1 union 2 is nothing but minus infinity to minus 2, union minus 1 to 0, union 0 to 1, union 2 to infinity. Now I can combine these two. I can write minus 1 to 1 directly. So my answer is minus infinity to minus 2, union minus 1 to 1, union 2 to infinity. This is the final answer. Whatever method we use to solve this inequality, it seems very lengthy. So for that, I have another alternate method. Now let me solve the same inequality using another method. Solve for x mod x minus 1 by mod x minus 2 more than or equal to 0. It's very simple inequality. Let us solve. Whenever these type of rational expressions are given on the right side, take first numerator and solve it for x. So first of all, take mod of x minus 1 is equal to 0 and solve it. Of course we get x is equal to plus or minus 1. Similarly, take mod x minus 2 is equal to 0, therefore x is equal to, we have plus or minus 2. This plus or minus 1 and plus or minus 2 are called critical points for the expression mod of x minus 1 upon mod of x minus 2. Okay, now take a real line. After finding the critical points, you have to take a real line and you have to locate these critical points on the real line based on their magnitude. First, of course, we'll get minus 2, next we'll get minus 1, next we'll get 1, next we'll get 2. So my real line is divided into 1, 2, 3, 4, 5 intervals. And we are going to select which intervals are suitable for my expression. So what is given expression? Given inequality. Equality mod x minus 1 by mod x minus 2 is more than or equal to 0. Okay, now take the first interval 1, and select any one real number from this interval. Say for example, we take minus 3. For x is equal to minus 3, if you substitute on left hand side, LS, this is mod of minus 3 is 3 minus 1 is 2, positive. Mod of 3 minus 2, 1 is also positive. Positive by positive is positive. Therefore, LHS is greater than 0. Therefore, we take the first interval. That means the first and every real number from the first interval is satisfying the inequality. Come to second one. Take this one. Minus 2 to minus 1. When you take minus 2 to minus 1, say for example minus 1.5. For x is equal to minus 1.5. Of course, minus 1.5 mod minus 1 is positive. Mod of minus 1.5 minus 2 is negative. Positive by negative is negative. So I don't want this interval. That means no real number from this interval is satisfying this inequality. So I don't want that. Let's come to minus 1 to 0. If you take minus 1 to 0, minus 1 to 1, minus 1 to 1, select any one real number from minus 1 to 1. Say for example 0. When you substitute 0 here, 0 minus 1 by 0 minus 2, negative by negative is positive. So I can take this interval and go for 1 to 2. Now just all you have to select, we have tested between minus 2 to minus 1, same character between 1 to 2 also. So I don't want this interval also. Next, more than 2, obviously positive. Therefore, these three intervals are valid for this expression, for this inequality. Therefore, the answer is x belongs to first one, minus infinity to minus 2. Minus infinity side open interval minus 2. Can I take minus 2? No, I can't take. Why? Because mod of minus 2 is 2. 2 minus 2 is 0. Anything by 0 is not valid. So I can't take minus 2. So minus 2 side also interval. Union. Next, minus 1 to 1. Minus 1 to 1. Now, can I include minus 1 plus 1? Yes, I can include. Why? Because when I put minus 1, mod of minus 1, 1 minus 1, 0. 0 by everything is 0. Therefore, I can take. As usual, I can take 1 also. Same case in the case of 2 to infinity. 2 to infinity. Therefore, mod x minus 1 by mod x minus 2 is more than or equal to 0 implies my x belongs to minus infinity to minus 2 union minus 1 to 1 union 2 to infinity. Next question, find the domain of f of x is equal to 1 over root of 4x minus mod of x square minus 10x plus 9. Okay, now solution. Now this function is in the form of 1 by root f. If f domain of f is equal to a real number set or subset of real number set, then what is domain of 1 by root f? It is simply x such that my f of x is more than 0. Right? Now I am going to apply this rule here. Therefore, here domain of 1 by root f is equal to x such that my f of x is more than 0. Therefore, we have domain is equal to x such that 4x minus mod of x square minus 10x plus 9 is more than equal. Right. So, take the inside expression. Now, 4x minus mod of x square minus 10x plus 9 is more than 0. Mod is involved, you have to remove the mod symbol. Then how do you remove mod symbol? Mod symbol depends on the sign of x square minus 10x plus 9. Now here you have to decide in which interval x square minus 10x plus 9 is positive, or in which interval x square minus 10x plus 9 is negative. How you decide? It's very simple. Now we know that x square minus 10x plus 9 is more than or equal to 0 implies my x is less than or equal to 1 and x is more than or equal to 9. Case 1. And we know x square minus 10x plus 9 is less than 0 implies my x belongs to 1 to 9. So, two cases you have to discuss. So, case 1. Case 1. X less than or equal to 1 and x is more than or equal to 9. So, remove mod symbol, put positive sign. We have 4x minus x square minus 10x plus 9 is greater than 0, or we can go for x square plus 14x and minus 9. Of course, this is the minus. So we have greater than 0 or x square minus 14x plus 9 is less than 0. So this implies my x belongs to 7 minus root 40 to 7 plus root 40. Now, not finite. You have to collect all those real numbers which are intersection of these two intervals. How? So, first I take help of the real line. This is infinity, negative infinity. I will go for 1 somewhere here, 9 somewhere here. That is, and 7 minus root 40, it lies somewhere. 7 minus root 40 somewhere here, and 7 plus root 40 somewhere here. Now, common to these two is this one and this one. Therefore, in this case, my x belongs to 7 minus root 40 to 1 union 9 to 7 plus root 40. Now, my question is, can I include 1 and 9? Yes, I can include. Why? Because if I put 1 or 9, this part will become 0. 4 times of number, positive number, root of positive is positive. So, I can take 1 to 9. Okay, next one. Next, case 2. Case 2. X belongs to 1 to 9. When x belongs to 1 to 9, we have, this implies my x square minus 10x plus 9 is less than 0. So, we get 4x plus x square minus 10x plus 9 is greater than 0, or I have x square minus 6x plus 9 is more than 0. This implies my x minus 3 whole square is always positive. So it is always positive, greater than 0, because square of number I can take in there. Can I take x equal to 3? No, I can't take. Why? Because 3 minus 3 is 3, 0. 0 square is 0, not more than 0. So x is not equal to 3. Now common to these two. 1, 9 common to these two. Therefore, I have x belongs to 1 to 9 minus 3. So this is number 2. Therefore, my answer is either this or this. Therefore, x union of 1 and 2 is obviously 7 minus root 40 to 1, 9 to 7 plus root 40, and 1 to 9. If you take these two, we get 7 minus root 40 to 7 plus root 40. Of course, 3 is not included, so you have to remove the 3 part. So, this is the final answer. Let's take it. Next, second question, mod of x minus 3 plus mod of 4 minus x is equal to 1. Okay, I can solve this equation also by using the earlier method. How? Take x minus 3 and solve it for x. X is equal to 3. Then go for 4 minus x. X is equal to 4. Then locate all the real number 3 and 4 on the real line. Then select which interval is possible. But if you apply the properties of the mod, we can solve it in just 1 or 2 steps. What is the property? Now look here, solution. We have mod of x minus 3 plus mod of 4 minus x is equal to 1. Now I am going to rewrite this as mod of x minus 3 plus mod of 4 minus x is equal to mod of x minus 3 plus 4 minus x. That means I can write this one as sum of these two expressions. Now it looks like mod of f of x plus mod of g of x is equal to mod of f of x plus g of x. When it is possible? Only is possible if the both are negative or both are positive. Is possible. It is possible. Only if f of x and g of x both are positive or negative. Indirectly, when the two numbers are both are positive, both are negative, their product must be positive. Therefore, this is same as f of x into g of x is more than or equal to 0. And what is f of x? What is g of x here? This implies x minus 3 times 4 minus x is more than or equal to 0. Or this is very simple. X minus 3 times x minus 4 is less than or equal to 0. Very simple inequality. This implies, you know very well, x belongs to 3 to 4 closed interval. That's all. Next question, mod x plus mod of x plus 4 is equal to 4. Now, this problem also can solve by using the same property. Or you can go for the actual method by solving the expressions for x. That means here x is equal to 0, x is equal to minus 4. Now locate this minus 4 and 0 on the real line and select which is suitable. But the process is very lengthy. Instead of that, look here. So solution. I have mod x plus mod of x plus 4 is equal to 4. If you observe carefully, this is the difference of these two. Therefore, I can write this as mod of x plus mod of x plus 4 is equal to mod of x plus 4 minus x. Of course, you can write x minus x plus 4 also, because you have mod, you get anyhow 4 you will get. So it looks like it looks like mod x, mod f of x plus mod g of x is equal to mod of f of x minus g of x. When it is possible? When one is positive, other is negative. That means if f of x is positive, g of x must be negative. Or if f of x is negative, g of x must be positive. Or indirectly, the product of f of x and g of x must be negative. That means less than 0. This implies I write f of x times g of x is less than or equal to 0. So what is my f of x here? Very simple. X times x plus 4 is less than or equal to 0. Now it is very simple. X belongs to minus 4 to 0. See how simple? If you apply the property, within seconds you will get the answer. If you don't apply, it takes very lengthy. Even I need to clear the board 2 to 3 times. Please take it. The next problem is find the domain of f of x is equal to cos inverse of 1 minus 2 mod x by 3 plus log x base mod x minus 1. So this function is again sum of the two functions. So solution. When the function is sum of two functions, then you have to find the domain individually, then you have to take their intersection. So first we take domain of this function, then we take domain of this function, then we go for intersection of those sets. Okay, now take cos inverse of 1 minus 2 mod x by 3. And you know very well what is domain of cos inverse function? Minus 1 to plus 1 closed interval. Therefore, my x subset minus 1 less than or equal to 1 minus 2 mod x by 3 less than or equal to 1. Is the case. So take separately and solve it. This implies minus 1 less than or equal to 1 minus 2 mod x by 3 less than or equal to 1. This is same as minus 3 less than or equal to 1 minus 2 mod x less than or equal to plus 3. I don't want 1, so add negative 1. This implies minus 4 less than or equal to minus 2 mod x less than or equal to 2. I don't want this 2 also. Divide entire one with the 2. So we have minus 2 less than or equal to minus mod x less than or equal to 1. Okay, now this expression is negative expression is given. Negative expression. Now, whenever you have negative expression, you have to take care a little. More care you have to take. Okay, now we have expression. Now we need to solve. How? I don't know. Listen carefully. Suppose if you have a less than or equal to some mod of some f of x less than or equal to some b. Take first mod of f of x less than or equal to b and solve it. Then go for a less than or equal to mod f of x, solve it. Then find the intersection of these two. This is the concept is here. So take first I'll take one minus mod of x less than or equal to 1. Or this implies I'll go for mod x is more than or equal to minus 1. When you multiply both negative sign, the inequality less than or equal to will change to greater. Now if you observe carefully, mod x is always positive and a positive number is always more than minus 1. So in this case, what is solution? My solution is x belongs to real number set. That is point 1. Next come to next one. Minus 2 less than or equal to minus mod x. Or I can say this implies 2 is greater than or equal to mod x. or this implies, because the less than, when you multiply both sides negative sign, the less than or equal to will become more than equal to. 2 less than or greater than equal to mod x is same as mod x is less than or equal to 2. And you know very well how to remove mod. This implies my x belongs to minus 2 to plus 2. So here the first one, from the right hand side I got real number set, from the left hand side I got minus 2 to plus 2. You have to take intersection of these two. So finally, therefore in this case, real number set intersection minus 2 to plus 2, obviously minus 2 to plus 2. Why? Because minus 2 plus 2 closed interval is subset of real number set. So I got a domain for the first function. Come to second one. Take log x base mod of x minus 1. It's a log function. So what is domain of log function? X must be more than 0 always. Okay. First we have x is more than 0. And what is about mod of x minus 1? The base must be positive. Of course, because of the mod, it's always positive, but never be equal to 1. Therefore, mod of x minus 1 is not equal to 1. What the meaning of that one? When x minus 1 is not equal to 1. Okay, if mod of x minus 1 is equal to 1, this implies my x minus 1 is equal to or minus 1. So when I take plus 1, will become x is equal to 2. If I take minus 1, x is equal to 0. So I can't take x is equal to 2 and x equal to 0. I have one more doubt. Can I take x is equal to 1? If I substitute here 1 minus 1 is 0, here it should not be 0 also. That means I can't take x is equal to 1 also. I can take x is equal to 1 also I can take. So I write totally my x is not equal to 0 and x is not equal to 1 and x is not equal to 2. That means all the real numbers except this you have to take. So my answer, x belongs to 0 to 1, I will take union 1 to 2, I will take union 2 to infinity. This is number 2 and this is number 1. Now you have to go for intersection of these two. You have to go for intersection of these two. First one minus 2 to plus 2. Second one 0 to 1. Okay, I will take 130 some space. Minus 2 to plus 2. Okay, now 0 to 1. Somewhere here, yes, I can take this one. Next 1 to 2, also I can take next one. Next 2 to infinity. Now, what are the common real numbers? Only between 0 and 1, 1 and 2. Therefore, my x belongs to 0 to 1 union 1 to 2. Next question. Given y is equal to 2 times of integral part of x plus 3 and y is equal to 3 times of integral part of x minus 2 plus 5. Find the value of integral part of x plus 5. Solution. Given y is equal to 2 times of integral part of x plus 3, let this is 1. Number 2 we have y is equal to 3 times of integral part of x minus 2 plus 5. I think we can solve, we can simplify the second one. How we can simplify? We have integral part of x plus n is equal to integral part of x plus n, where n is integer. So using this concept, I can write 3 times of integral part of x minus 2 plus 5. Now just open the bracket. We have 3 times of integral part of x minus 6 plus 5 or 3 times of integral part of x minus 1. This is number 2. Now just these two are two linear equations you have to solve them. First I will go for elimination of 5. Eliminating y, we get 2 times of integral part of x plus 3 is equal to 3 times of integral part of x minus 1, or you can have integral part of x is equal to 4. Integral part of x is equal to 4 means my x value can be 4 or more than 4, but not more than 5. It has to upper boundary 5. This implies I can write my x belongs to 4 to 5. 5 is not included. Or I can say my x is equal to some 4 plus some fraction. Any fraction lies between 0 and 1. Okay. Now substitute this x value either in 1 or 2. Okay. Put x value in 1. So we have y is equal to 2 times of, there is nothing but 4 plus some fraction plus 3. So 4 plus integral part of 4 plus something is again 4. So we have 2 4s are 8. 8 plus 3 is equal to 11. Therefore, we have x is equal to 4 plus some fraction and y is equal to 11. We want integral part of x plus y. So nothing but 4 some fraction plus 11, of course nothing but 15. Therefore, integral part of x plus y is equal to 15. In the domain of integral part of sin x times cos of pi by integral part of x minus 1. So my f of x is equal to integral part of sin x times cos of pi by integral part of x minus 1. It is just product of two functions. That means you have to find domain of this function and next domain of second function and then find their point of intersection. Find their intersection. Now integral part of sin x. Integral part of sin x depends on sin x and the domain of sin x is a real number set. Therefore, for integral part of sin x, x belongs to R, entire real number set. Come to second one for cos of pi by x minus 1 integral part. This cos of pi by something. Now you find variable here. This integral part of x minus 1 should not be 0. Then it is defined because anything by 0 is not defined. So here x such that integral part of x minus 1 is not equal to 0. Okay, if integral part of x minus 1 equal to 0, if x minus 1 integral part is equal to 0, what is the meaning of that? My x minus 1 belongs to 0 to 1, close and 1. Or this implies my x belongs to 1 to 2. That means I can't take a real number between 1 and 2 except that it is defined. Okay, therefore x does not belongs to domain. Therefore here for cos of pi by integral part of x minus 1, x such that x does not belongs to 1 to 2. But before finding the answer, we cross check. Can I x is equal to 1? No, I can't take x is equal to 1. Can I take any value less than 1, more than 1, less than 2? For example, 1.5. Integral part of 1.5 minus 1 is 0.5. Integral part of 0.5 is 0. So I can't take. So I can't take any number. Okay. Therefore, that is equal to 2 and is equal to 1. So what the answer? Therefore, domain is equal to all the real numbers except 1 and 2. Next question. Given y is equal to 2 times of integral part of x plus 3 and y is equal to 3 times of integral part of x minus 2 plus 5. Find the value of integral part of x plus 5. Solution. Given y is equal to 2 times of integral part of x plus 3, that is 1. Number 2, we have y is equal to 3 times of integral part of x minus 2 plus 5. I think we can solve, we can simplify the second one. How we can simplify? We have integral part of x plus n is equal to integral part of x plus n, where n is integer. So using this concept, I can write 3 times of integral part of x minus 2 plus 5. Now just open the bracket. We have 3 times of integral part of x minus 6 plus 5 or 3 times of integral part of x minus 1. This is number 2. Now just these two are 2 linear equations you have to solve them. First, I will go for elimination of y. Eliminating y, we get 2 times of integral part of x plus 3 is equal to 3 times of integral part of x minus 1, or you can have integral part of x is equal to 4. Integral part of x is equal to 4 means my x value can be 4 or more than 4, but not more than 5. It has to upper boundary 5. So this implies I can write my x belongs to 4 to 5. 5 is not included. Or I can say my x is equal to some 4 plus some fraction. Any fraction lies between 0 and 1. Okay. Now substitute this x value either in 1 or 2. Okay. Put x value in 1. So we have y is equal to 2 times of, there is nothing but 4 plus some fraction plus 3. So 4 plus integral part of 4 plus something is again 4. So we have 2 4s are 8. 8 plus 3 is equal to 11. Therefore, we have x is equal to 4 plus some fraction and y is equal to 11. We want integral part of x plus y. So nothing but 4 some fraction plus 11, of course nothing but 15. Therefore, integral part of x plus y is equal to 15. Please take it. Next one, find the domain of integral part of sin x times cos of I by integral part of x minus 1. So my f of x is equal to integral part of sin x times cos of pi by integral part of x minus 1. It is just product of two functions. That means you have to find domain of this function and next domain of second function and then find their point of intersection. Find their intersection. Now, integral part of sin x. Integral part of sin x depends on sin x and the domain of sin x is a real number set. Therefore, for integral part of sin x, x belongs to R, entire real number set. Come to second one for cos of pi by x minus 1 integral part. This cos of pi by something. Now, you find variable here. This integral part of x minus 1 should not be 0. Then it is defined because ending by 0 is not defined. So here x such that integral part of x minus 1 is not equal to 0. Okay, if integral part of x minus 1 equal to 0, if x minus 1 integral part is equal to 0, what is the meaning of that? My x minus 1 belongs to 0 to 1, closed and 1. Or this implies my x belongs to 1 to 2. That means I can't take a real number between 1 and 2 except that it is defined. Okay, therefore x does not belongs to domain. Therefore, here for cos of pi by integral part of x minus 1, x such that x does not belongs to 1 to 2. But before finding the answer, we cross check. Can I x is equal to 1? No, I can't take x is equal to 1. Can I take any value less than 1, more than 1, less than 2? For example, 1.5. Integral part of 1.5 minus 1 is 0.5. Integral part of 0.5 is 0. So I can't take. So I can't take any number. Okay. Therefore, that is equal to 2 and is equal to 1. So what the answer? Therefore, domain is equal to domain is equal to all the real numbers except 1 and 2. Please check it. Next question, find the domain of f of x is equal to log of 5 minus integral part of x minus 1 minus integral part of x whole square over x square plus x minus 2. Solution. It is a rational function. What is domain of rational function? Suppose we have f of x is equal to some p of x by some q of x. What is domain of f of x here? Domain of f is equal to domain of p intersection domain of q minus x such that q of x is not equal to 0. This is a basic method. Okay. Now, first domain of numerical first we find. Okay, now take log of 5 minus integral part of x minus 1 minus integral part of x square base 4. Since it is a log function, obviously this expression must be more than 0. That's all. Therefore, x such that 5 minus x minus 1 integral part minus integral part of x square is positive. That's all. So take separate that one and simplify it. Take 5 minus integral part of x minus 1 can be written as integral part of x plus 1 minus integral part of x square is more than 0. Or we go for integral part of x square plus integral part of x 5 plus 1 6. So this is equal to minus 6 less than 0. Yes, obviously it is just a quadratic inequality. If domain of y is equal to f of x is minus 3 to 2, find the domain of g of x, where g of x defined as f of mod of integral part of x. Okay, now let's see the solution. Solution. For the function y is equal to f of x, by x belongs to minus 3 to 2. Okay, now you have to find the domain of this one. And g of x is equal to f of mod of integral part of x, this one. So input for the x is taken from minus 3 to 2. Here f function defined on mod of integral part of x, that is domain of g of x. So indirectly they are asking, therefore domain of g of x is nothing but solution of this equation inequality. Domain of g of x is x such that minus 3 less than or equal to mod of integral part of x less than or equal to the basic. So take the inside one, minus 3 less than or equal to mod of integral part of x less than or equal to 2. So here actually the question is solve inequality, and it is given in different form. That's all. So here we have one mod, one integral, both notations are there. Now you have to remove that mod and integral part. So to solve the equation, which one we need to remove first? Now my suggestion is, in this type of questions, remove mod symbol first, then go to the next one. So here, what is the mod property? I am going to remove the mod symbol. What is the mod? Mod is always positive. Therefore, I can write 0 less than or equal to mod of integral part of x less than or equal to 2. Okay, now I need to solve this equation. Mod of integral part of x less than or equal to 2. Now remove mod symbol by using, now we know that mod of f of x or some p of x, mod of p of x less than or equal to a, this implies minus a less than or equal to p of x less than or equal to a. So here we need to do integral part of x minus 2 less than or equal to less than or equal to 2. Now you need to remove integral part symbol using that integral part. So we have minus 2 less than or equal to integral part of x less than or equal to 2. First we take this. Integral part of x less than or equal to 2, this implies my x is less than 3. Why? Because we have property integral part of less than or equal to n, this implies my x is less than n property. This is number 1. Number 2, integral part of x more than or equal to minus 2, this implies x more than or equal to 2. What a property here? I use integral part of x more than or equal to n implies x more than or equal to n. Now intersection of 1 and 2 is nothing but minus 2 less than or equal to x less than 3. Therefore, domain of g of x is equal to minus 2 to 3. Actually, it is not a question of finding g of x. How to remove the mod symbol and integral part symbol, which is the first. Now here we have to remove mod symbol always first, next any other symbol. That is the actual answer hidden in this question. You take it. Find the domain of f of x is equal to 1 over integral part of mod of x minus 1 plus integral part of mod of 7 minus x minus 6. Solution. Now it is just in the form of 1 by f. We know very well, we know that domain of 1 by f is equal to x such that f of x not equal to 0, or I can say or minus those real numbers for which f of x is equal to 0. I'll go for this point. So here domain is equal to r minus x such that mod of integral part of mod x minus 1 plus integral part of mod 7 minus x minus 6 is equal to 0. So we have to solve this equation. So take x such that, or take integral part of mod x minus 1 plus mod integral part of mod 7 minus x minus 6 is equal to 0. So you have to solve. How we can solve? Just now I told, whenever you have mod and any other function, first try to remove the mod, then go to next one. So first I remove the mod. How I can remove the mod? Just by taking a real line method. Now what is that method? You know very well. What are the critical points here? Critical points are 1 and 7. So take real line. I'll give some space here. Okay, now minus infinity to infinity, and this is equal to 1 and 7. Case 2, 1 less than 7. Case 2, 1 less than x less than or equal to 7. So in this case, this x minus 1 will become positive, so integral part of x minus 1, and this also equal to integral part of 7 minus x minus 6 is equal to 0, or this is integral part of x minus 1 plus 7 plus integral part of minus x minus 6 is equal to 0. Therefore we have integral part of x plus integral part of minus x is equal to 0. Okay, here also again two cases, x is integer, x is not integer. If x is an integer, we have integral part of x minus integral part of x is equal to 0. Of course, x can be any integer in this interval. Therefore, we have x is equal to, what are the integers between 1 and 7? 2, 3, 4, 5, 6 and 7. Next one, if x is not integer, we have integral part of x minus 1 minus integral part of x is equal to 0. So we have minus 1 is equal to 0. So no solution. So in the under second case, we got solution 2, 3, 4, 5, 6, 7. Case 2. Case 2, we have 2, 3, 4, 5, 6 and 7. is 7 less than or equal to x, sorry, less than x less than 8. Sorry, infinity. Infinity. Okay, now in this case what happened? Integral part of mod of x minus 1. X minus 1 is positive, so we have x minus 1 plus 7 minus x will become negative, therefore we have minus 7 minus x. Minus 6 is equal to 0. So this is nothing but integral part of x plus minus 7 plus x. So this is minus 7 plus integral part of x minus 1 minus 7 plus integral part of x minus 6 is equal to 0, or we have integral part of x is equal to 7. Integral part of x 7 means we have, this implies 7 less than or equal to x less than infinity, sorry, is 8. But here we have taken open interval because of these two, we have 7 less than x less than 8. So case 3. Case 3, 7 less than x less than 8. That means in all these cases, integral part of mod x minus 1 plus integral part of 7 minus x minus 6 is becoming 0. So we don't want these numbers. So we need to take a real number set except this. Therefore, finally, domain is equal to or minus. What is the first one? 0 less than or equal to x. Sorry, 0 less than x less than or equal to 1. Or I'll go for 0 to 1 close open union 7 to 8 open interval minus 1 discrete set that is equal to 2, 3, 4, 5 and 6. This is the domain. Please. Solve 4 times of fractional part of x is equal to x plus integral part of x. Solution. What is given? 4 times of fractional part of x is equal to x plus integral part of x. So what I do, I write x is equal to 4 times of fractional part of x minus integral part of x. That is what? Because I want to find x value. Okay, again 4 times of fractional part of x is equal to, in the place of x I can write always integral part of x plus fractional part of x. Of course, the remaining is as it is. I am writing x as integral part of x plus fractional part of x because you know very well. Now, please simplify this. We have 3 times of fractional part of x is equal to 2 times of integral part of x. Now I can write either fractional part of x as subject or integral part of x subject. But I know the limits for fractional part of x. That's why what I do, I write fractional part of x is equal to 2 by 3 over fractional integral part of x. Now we know fractional part of x always lies between 0 and 1. Therefore, it also must lie between 0 and 1. We know that 0 less than or equal to fractional part of x less than 1. Therefore, 0 less than or equal to 2 by 3 into integral part of x less than 1, or 0 less than or equal to 2 integral part of x less than 3, or 0 integral part of x less than 3 by 2. So my integral part of x lies between 0 and 3 by 2. Now you know very well, integral part of x is integer. Therefore, which are the integers between 0 and 3 by 2? They are 0 and 1. Therefore, integral part of x is equal to either 0 or 1. Now, use these results, this 3, in 1, in 2. Therefore, if integral part of x equal to 0, then fraction part of x also 0. Sorry, if the integral part of x is equal to 0, then from 2, fraction part of x also 0. Next, if integral part of x is equal to 1, then fraction part of x is equal to 2 by 3 times of 1, that is equal to 2 by 3. Now we can find x value. Therefore, number 1, if integral part of x equal to 0, fraction part of x equal to 0, then x is equal to 0. Why? Because my x is equal to 4 times of 0 minus 0. Next one, b. If integral part of x equal to 1, fraction part of x equal to 2 by 3, then my x is equal to 4 times of 2 by 3 minus 1, which is nothing but 8 by 3, 5. Therefore, my x is equal to either 0 or 5 by 3, which is solution.